Hi, so this question is on, this is 2021 AP Calculus Exam AB, question number 4. It's a non-calculator question, very common one. Says let f be a continuous function on the closed interval. The graph of f is shown to us, and we have another function g that's defined as the integral function from 0 to x of f of t dt. The first question is on what open intervals is the graph of g going to be concave up? So concave up means the second derivative is going to be positive. So what we're going to need to do is first we need to connect all that. So g prime of x is going to be f of x, because we differentiate the integral function. G double prime of x equals f prime of x. So we want that to be positive. So where is it going to be positive? Let's take a look at the graph. Wherever the slope is positive, f prime is going to be positive, therefore g double prime is going to be positive. That happens on -4 to -2 and also 2 to 6. So that happens on -4 to -2 and 2 to 6. So we can conclude now, we should write the conclusion here. So g of x is concave up on -4 to -2 and 2 to 6 because g double prime of x is, I'm sorry, I was going to write positive because we do need to justify, so positive on those intervals. Okay, that's all for A. B. It's telling us that P of x is G of x times F of x, and we need to find P prime of 3. So we're going to have to use the product rule. That's the first thing we're going to need to do. So P prime of x equals G prime of x times F of x plus G of x times F prime of x. All we did here is just use chain rule. So P prime of 3 will be G prime of 3 times F of 3 plus G of 3 times F prime of 3. And we need to figure out all these values now. Now, one thing we know already, that G prime of 3 and F of 3, that's actually the same exact thing. What is it? So when you evaluate F of 3, which is also going to happen to be G prime of 3, it's going to be right here on the graph, and that's going to be a value of -3. So both these values are going to be -3. So this is -3 times -3 plus, to find g of 3, g is defined as the integral function from 0 to 3. So we got to do the integral from 0 to 3. So if you look at this, you have this triangle here and this triangle here, which are going to have the same area, but one's positive, one's negative, so those two things will cancel. And the only thing that's going to be left then is this trapezoid, whose area you need to find, but please remember, since that trapezoid is below the x-axis and we're going to the right, then that area is going to be positive. I'm sorry, negative, right? So the area here is going to be -1/2 times the height, which is 1, times the two bases, which is 4 plus 3. And then times f prime of 3 will be the slope of that line, which is 1. So times 1. And after you do all this math, you're going to get 11/2 for the answer. Okay. Next question, C. Find the limit of the g of x over x squared minus 2x as x approaches 2. So what's going to happen here, let's take a look at this first. Obviously the denominator is going to be 0 when you substitute 2. What happens in the numerator? G of 2 is going to be the integral from 0 to 2 f of t dt, which is also going to be 0. So both values are going to end up being 0, which means it's probably a candidate for Lopital's rule. So first of all, limit of g of x over x squared minus 2x, x approaches 2. College Board, if you're doing this for an AP Calculus exam, College Board does not like when you write 0 divided by 0. It's not proper. So what we do is we're going to write individually each limit as being 0. Okay, so we know it's 0 divided by 0. So what do we know? Since g of x is differentiable, and x squared minus 2x is differentiable, then Lopital's rule applies. I don't know why I put a comma here. Let's get rid of it. Okay, and then we can go ahead and take care of that. So that would require us to do what? So we know that the limit as x approaches 2 of g of x over x squared minus 2x. We take the derivative of the numerator, which is going to be g prime of x. We take the derivative of the denominator, which is 2x minus 2. Right, and now substitution is fine. The numerator is going to give us negative 4, the denominator will give us 2, and the answer is going to be negative 2. Okay. And our last question here is going to be find the average rate of change of g in the interval from negative 4 to 2. Does the mean value theorem guarantee that there is a value where g prime will equal to that? Well, let's find the average value first. So the average value is going to be g of 2 minus g of negative 4 divided by 2 minus negative 4, which is going to be 8/3 once you substitute all the values. So does the mean value theorem apply here? And yes, because the function needs to be continuous and differentiable. So we know since f of x is continuous, we know g of x is continuous and differentiable. It's continuous on the closed interval from negative 4 to 2 and differentiable on an open interval from negative 4 to 2. Therefore, the mean value theorem applies. So the answer is yes, such value exists. Therefore, there exists some c, which is going to be between negative 4 and 2, such that g prime of c is going to equal 8/3. Okay, and that's all for this problem.